Hello. So we're going to continue now by converting the tables that we built, or rather that we had schemas for, into SQL, which allows us to actually put them inside a real database. So SQL is the structured query language. This is the main language that we use to talk to relational databases. And today they're even used a lot to talk to non-relational databases. So this is something that you just simply have to know as a professional programmer. So SQL actually has two different query languages, really. The first one is called the data definition language, or the DDL, and that is used to define relations, constraints, and other things that talk about what the components of the database are. You know, what tables does it have, what are the names of the attributes, etc. Okay. Then there's the data manipulation language, which is really what's used to query the database and to modify the rows that are in the database. Okay. Right now we're just going to deal with the data definition language. There's going to be like 4 chapters devoted to the manipulation language in the future. Okay, so we have 3 different types of relations. Okay, there are tables. These are our basic relations. These are the things that we store on disk. Most of the time, that's what you've been thinking about, right? When we think about a table, we think of something that is just there, and it's got a bunch of rows that we're familiar with. There are also views. Views are tables that are ephemeral. I mean, they get created and destroyed essentially on demand. In a sense, they really are just queries that the database stores for us so that we don't have to keep issuing the same query over and over again. An example here is that you can have a table that has all the movies, and then we can have a view that has only the movies that Kevin Bacon stars in. So that would be a subset of those movies, and that's the kind of thing that you can do with a view. We also have temporary tables. These are just tables that either the user creates or oftentimes the database system itself creates. And they're simply used because in the process of a computation, you might want to store some results and hold them for a while. Okay. For instance, we might create a temporary table and then sort it because that helps the computation. Okay. To actually deal with stored relations or tables, right? You know, the most important one. We use the SQL command called create table. That's it. And to do it, you have to provide the name of the table, the names of the attributes, the types of the attributes, the keys. In the future, we'll see constraints and all of that will just show up right here in that thing. Now, we're going to move and start showing you those create table commands, but I have to start with a very big warning, okay? SQL is, quote, standard. And what that means is that ANSI, which is the American National Association for Standards, actually Standards Interchange, Institute rather. Anyway, ANSI has an actual document that says this is what SQL is supposed to look like, okay? But it doesn't enforce that. So, for example, there is no test suite that you have to run to check to see whether you are compliant. So, if you want to call yourself SQL compliant, go ahead, okay? That means that you might have some of the commands, but not all of them. It might also be that you use different names for things. Instead of number, you might call it numeric. Instead of date, you might call it date time, etc. So different vendors just have slightly different, sometimes wildly different versions of SQL. You have to look at the database manual for your database. When I'm programming, when I'm doing database work, I keep the manual next to me. That is really easy to do these days because I just have a page on my web browser that's just pointing right to the manual so I can check for anything that might come up. Okay, so in this class we're going to talk about the standard stuff. That will probably work in most different systems that you use, but there are going to be some differences. So when you're working with a particular database for your projects, keep that in mind. Okay, all right. So the first thing you should know is the different data types that we have in SQL. This is a list of the standard data types. Not all of them. It's not an exhaustive list. But honestly, right here, you'll find that whatever database you choose probably does not implement all of these. Okay, I'm sorry, that's life. So char, char, parentheses, and then you have the length. So you can say, I have a character field that has 10 characters in it. Char means it really has 10 characters. Okay, so if you say char 10 and then try to put Fred into it, Fred is only 4 characters. So what it will do is it will pad it with 6 spaces after Fred. So it'll be Fred space, 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 space. Okay. Varchar n means that it can have up to n characters. Varchar 10 means up to 10. If you store Fred, that's okay, right? It's just 4 characters. Bit is a fixed length, n bits. Bit varying, why not var bit? I don't know. Okay, I didn't make it. It's just a loose standard. Bit varying n means, it could be 10 bits, but it could also be fewer. Okay. Boolean is true, false, or unknown. We're also going to talk about a data type called null, which means, well, actually nobody really knows what it means, but it's often used to mean I just don't have data for this. So that could be true, false, unknown, or null. The difference between unknown and null is really subtle, right? And your database may not support unknown. Int, integer, that's just a number, okay? It may use the underlying int type, which is, 32 signed bits, or it may not, okay? They may choose to do something different. For example, they may have int means numbers up to 12 digits, okay? That just depends on your database. We also have float, also sometimes called real. It's what you think it is. It's a single precision number. We have double precision, which is a double precision number. Okay. It could be that float is actually a double. Okay. But then double will be double. Okay. So that's, again, that just depends on your database, exactly what they mean by float and double. Decimal actually lets you specify, I really have, 12 digits, and 3 of those come after the decimal point, for example. The virtue of doing that is that if you're storing money, okay, it is actually safer to store money as decimal, where you can specify the digits of precision and the decimal point, than it is to use a float or a double, because you never know exactly when a rounding in a double will change a large amount by, say, $1. And if you're talking in the billions, $1 doesn't really matter, right? But that will throw off an accounting program by quite a bit, so you don't want to push that. Then there's numeric. Different databases interpret numeric differently. Some of them don't even have the type numeric, but numeric is whatever default the database has for numbers. So it could be an integer, it could be a float, it could be a decimal 92. There's no way of knowing unless you check the database manual. There's a date. Okay. Some databases actually treat dates as strings, so it's simply a string in the format YYYY-MM-DD. Notice that if you have it like that, you can compare strings, dates, to see whether one date is before another one, and the string comparison works perfectly for that purpose. So that really is the way some databases store it. Other databases store it differently, like number of milliseconds since January 1st, 1970, or something even crazier, okay? It just depends on your system. There is time. Time should be, well, it could be a string again, okay? So 14, 25, 30.6, that's a very precise time. That is 2 p.m., 2:25, 30 seconds, 6/10 of a second. You could have a date time, which combines a date and a time. Could also be stored as a string, and this shows you an example of how to do that. It could also be stored as a number. It just depends on what your database wants to do. There is duration. Okay, duration is a period of time. So that is not 1 hour and 20, as in it is 1:20 according to my watch. That is, we've been talking for 1 hour and 20 minutes. Okay, that's what a duration is. These are all standard SQL types. Your database may have some of these. Okay, you have to consult the manual. All right, so now that we've done that, let's create a table. So we'll use the create table command. We need to provide the name of the table. So we have create table movies. And then this is not a brace, okay, as in C, C++. This is a parentheses, a left parentheses. And then we have just a list of names of the attributes, title, year, length, genre. And what we have is the name, and then a space, and then the type or the domain. So create table movies, title, varchar 100. Why? I wouldn't want to make it a car because I want to have variable length. 100 seems like it's big enough, okay, for a movie title. If we're wrong, maybe we should make it larger, like 1024, okay? Keep in mind, though, that just because this says varying, you don't know how it's stored in the database. It could be that it actually allocates that much space, And if you only use 80 characters out of 1,000, then the remaining 920 are just lost. Okay, so that depends on the details of your database. Some databases are better about strings than others. But anyway, here's just an example of how to create the movies table. Notice the semicolon at the end. Okay, that is actually not part of the standard. The standard doesn't say how statements are terminated. Most databases accept semicolons. Some accept other terminators. For example, Oracle likes the word go as the separator. So create table, close parentheses, go. This is another table, movie stars. And again, we have a name and an address. It's a var car. And gender is a car. We can get away with car here because it's only male or female. Okay, so M or F will work. And birth date is an actual date. Okay, it's a perfectly reasonable use for that. Let's see. You may want to delete a table, okay? After you build it, you're like, oh, that's really not at all what I wanted. Let's just get rid of it and start over. All right, here are two verbs that you should know, drop and delete. And in SQL, they mean different things. So drop means I am done with this table. I don't want to hear about it again. Delete it. That table no longer exists, okay? Delete does not actually remove the table. What it does is it removes rows in the table. Okay, so if you say drop table movies, that table no longer exists. You can't ask any queries about it. It's gone. If you say delete movies, actually it's delete from movies, but don't worry about that now. But if you say that, what you're doing is you're deleting all the rows in the movies table so that you still have the table, but it is now empty. Okay, so there are different commands. Remember, drop changes the schema, delete changes the instance only. All right, let's modify a table. So altered table, in fact, altered verb is what we use to change any of the schema items. So in this case, we can alter the table movie stars, and then you say what you want to do. Alter table movie stars add. We're adding an attribute. So phone, that's the name of the attribute. Car 16, that's the type. Okay. Or we can also get rid of an attribute. Alter table movie stars drop birth date. Okay, notice it's drop and not delete because we are removing a schema element. We're not messing with the values in the cells. Okay, so that's how we could change the schema dynamically. I don't recommend doing that in general. Okay, I prefer to try to get it right. If nothing else, because when you add phone, it's not gonna go in a nice place. It's gonna just end up at the end. Okay, so so later you'll be looking and the attributes show off in very weird ways. I prefer to just try to get it right the first time. If I don't get it right the first time, if I can get away with it, I will drop the table, recreate it the way I want, and repopulate it. Okay, I have some bad news for you. And the bad news that I have is something called null values, which I talked a little bit about earlier. Okay, and here's where they come up. It's not something to do with databases. It's just real life. And real life is very difficult, very complicated. So in databases, it just inherits those. So we have a movie star. We want to add this movie star to our database, but the problem is that they didn't give us their phone number. So what do? Okay, that's what null value says. So essentially a null value means I have no idea what should be in here. Okay, every single domain has a null. If you're used to object-oriented systems, right, then you could think of, well, a string, that could be a null. But say an int, that can't be a null, okay, because it's a number, it's a 32-bit number, and there is no extra number that means null. Similarly, you might think like in Java, oh, there's a capital integer, that can be null, but a lowercase int can't be null, okay? Now, in databases, all that discussion just doesn't make sense. If you're a domain, then you have null as something that can be said. So yeah, there's actually a null integer. And it isn't equal to -1, for example. It isn't 0. It isn't 0 hex FFFFFFF. It's just some weird thing that is null and is not one of the standard integers. Okay. Now, the strangest thing about null is just trying to capture what we mean by null. Okay. So for example, we have two records, John and Sally. And both of them have null as their parent. Why? Because we don't know who their parent is. Okay, So we added them in the database. We have no idea who their mom is. We have no idea who their father is. So we put null in those fields. Okay, so since both John and Sally have null for a parent, does that mean that they're siblings? Well, not necessarily, right? I mean, just because I don't know who your parent is doesn't mean that everybody else that I don't know who your parent is your brother or sister. That doesn't make any sense. On the other hand, does that mean that they're not siblings? Well, that's taking it a little too far, right? If I have two people and I don't know who their parents are, that doesn't mean that they come from different families, right? They actually could be twins for all I know, and we just forgot who their parent is. So you can't really make an assumption one way or the other. How are you supposed to deal with this when you do a comparison? That makes it hard, and in fact there is no right answer, and it depends on what we're using null for. So it's just something to know. It's complicated, and whenever you start allowing nulls in your database, which by the way will be with the first database you build, you'll have to think about what you mean by null. Something else you can do is, instead of using null, you can have default values. Okay, so think of default values, for example, as being unknown, or in the case of a phone number, it could be unlisted. Okay, so that is like an explicit value that you and you alone know means I have no idea. The nicest thing about this is that you can actually program your system so that there are different ways of not knowing. It could be unknown. It could be known, but you're not allowed to see it. It could be, different variations, and so you can actually specify which one of those it is. Okay, so let's jump to keys. We have a table. We want to build a table, but we actually want to say what the key is. Okay. Now there are two ways to do this in SQL. If the key has only one attribute, so for example, in movie star's name was just an attribute, then you can simply say primary key after the domain. So in here we have varchar 100 space primary key. That works. Okay, you should know how to do that. It's very important. I'm going to ask you to do things like this in an exam. However, if you actually need more than one attribute, like title year, then you can't do that, because you can't just say primary key and title. I suppose they could have allowed you to say primary key and year as well, but actually that would be a syntax error. Okay, so instead what you have to do is somewhere, some databases require you to put it at the bottom, others don't care where you put it. So out of a habit, I always put it at the end of my create table definition. You say primary key, and then a parentheses, and then the attributes, comma separated, but a comma separated list of attributes that make up the key, and then a right parentheses. So in here, primary key is title, comma, year, okay, which is what we had in our main system. I actually prefer this. The reason is that it works for single attributes and multiple attributes. So I use the same trick for all my tables, but you should know how to do it both ways, and especially how to read it both ways, because you'll have to. Okay. Remember, it is possible for a table to have a choice of keys. So I could have chosen this, or I could have chosen that. Okay. What we have to do is pick one of those choices and run with it. That's what we call the primary key. Okay. So what do we do for the other ones? There's actually no secondary key, phrase in SQL, even though database people talk about primary and secondary keys. So instead, what you have to do is say that the other ones are unique. Okay. Remember that what we mean by key is that if you have the same value in two rows, that has to be the same row. In other words, that the different values of the primary key are unique. So if you have another one, you simply say, well, that's unique. So here is a social security number and student ID. We can choose primary key on student ID, unique on social security number. Okay. So I thought I had an example for that. I'm sorry. But it's actually done in the exact same way as primary key. So you can say, let's see, SSN, which would be a car 9 unique, or you can at the very bottom say unique and then parentheses SSN.